So now let's say we have a bit different scenario. Now our initial velocity is 5 meters per second. The ball is thrown and we're even given our heights. So the delta y for the building is 10 meters, and from the maximum height to the ground is 15 meters, which means that the distance from the building to the maximum height has to be 5 meters. But now we are asked to calculate, they are asked to calculate the V final. So they asked calculate V final just before it hits the ground. So V final here. So the V final, remember, just before it hits the ground, because remember it's accelerating downwards. So they ask us to calculate V final just before it hits the ground. So we can also do this also from the maximum height. How? Remember, now we're taking maximum height as our initial point, as the starting point. Remember, at the maximum height, what's the maximum height? 0. So that means now things are going to be a bit different. Our V initial will now be 0 meters per second, because now we are starting at the maximum height. And remember, if we are going from another state to the maximum height, the V final, the maximum height, it's 0, because that's where the ball ends. But now we are starting at the maximum height, so then it becomes that V final becomes our V initial. And we don't have time, we're not given time, so but we're looking for V final. And acceleration, remember we chose up as positive, so that this is going to be negative 9,8 meters per second squared. Then delta y, that's 15 meters. So now we need to choose an equation that does not have time, because we're not given time. So we'll choose the second equation. So Vf squared is equals to V initial squared plus 2a delta y. Now our V final is what we are looking for. V initial 0 squared plus 2 negative 9,8, because we chose up as positive, delta y. Okay, so now delta y, our displacement. Now this is also where most people get confused, because they're always like, okay, distance is always, the vector distance is always positive. So even, usually write distance as positive and then just indicate whether it's going east or west, north or south. But now then we're talking about displacement. So displacement can either be positive or negative, so depending on which direction I've chosen. Now I've chosen up as positive, but where is my ball going? My ball is starting upwards and it's going downwards, so it's going in the opposite direction from the distance that I've chosen. So that means I'm gonna write it as negative 50. So if this ball was thrown from downwards, so it was starting downwards going up, then I will keep my distance as a positive. For example, let's say I have the distance from the building to the maximum height. Let's say I wanted to calculate the time again from the initial state to the maximum height. Then I can use this 5 meters in the equation and to get the time. But in that case, I will substitute this 5 as positive, because the ball is going, it's starting down and it's going up. So it's going up, so my distance will be positive. But now this distance, because I chose up as positive, and this ball is starting upwards going downwards, so it means going in opposite direction, so my displacement is negative. So then I have 2 multiplied by negative 2,98 multiplied by negative 15, so that will give me V final squared is equals to 2 294. Then I put a square root, plus or minus. So then this gives me the final velocity of plus or minus 17, 17,15 meters per second. But remember, this ball is going downwards and I chose up as positive. So I can write it in two ways. I can say V final is equals to negative 17,15 meters per second. Or I can say V final is equals to a positive 17,15 meters per second. Then I indicate downwards. So I can write it in two ways.